Okay, thank you. Thank you all for being here this late in the afternoon on a beautiful day. I appreciate the attention. I'm a little curious about your interest in what I'm going to talk about, because this talk is going to be quite a bit different from all the others you might have heard today. I'm not going to show you any models, predictive models or things like that. I'm going to talk more about service. And maybe give you some perspective about what we're thinking in the United States, if that matters. Is anybody else here from the U.S.? Okay,
But we came extra for you, right?
I just came from a conference in Italy last week, so I did not come all the way here for today. I actually spent the week in Europe, and I really enjoy. I'm happy to be here because I find attending a conference that has not been liberated by the United States is actually, for me, very stimulating and informative. So I really enjoy coming to these. I'll explain in a minute my background data here. Virginia Tech is where I work. I am this year the president of an organization called ISIT. How many of you are members of ISIT? Krista, how many of you have heard of ISIT? Okay, I'll tell you in a minute. What about Informs? Any Informs members here? Besides Christoph? Okay, so this talk is going to be a little different. Informs is the Institute for Operations Research and Management Science, and that's my background. Christoph Heitz invited me to speak today because he and I have known each other for quite a few years now, initially through Informs. So my background is in operations research and operations management. And I became interested in service, I guess about 10 years ago, 10, 12 years ago. And what I'm going to talk about today has a lot to do with this thing called service. Human beings have been providing service for as long as they've been walking the planet, but it turns out that there's a new discipline called service science, believe it or not. And I say new, it pretty much was discovered, you might say, in 2004 or thereabouts. IBM led the way to some extent with something called SSME, Service Science Management Engineering. That term they don't use anymore, but that was their way of starting to acculturate their people and their customers into this thing called service. In 2004, there was a famous paper coming out of the marketing discipline about something called SDL. How many of you have heard of SDL? Put your hand down, Christoph. Everybody, you're just like the teacher's pet here. Service dominant logic. And that has initiated a whole new discipline called service science. Most people Informs is a good example. This is an organization that's been around since World War II. And you know about all of the modeling they've done in manufacturing and supply chain management and transportation and things like that. And that's exactly what I used to do. And the biggest interest group, a special interest group in Informs, is called MSOM. Manufacturing, Service, and Operations Management. They've got about 800, 900 members in that organization. And to them, and to most people, service is defined by the so-called IHIP model. Intangible, heterogeneous, instantaneous, and perishable. That's what defines service. And that's totally wrong. But that is still the doctrine that guides a lot of their thinking. So to them, a service system is a queuing system. And you treat patients in a hospital, customers in a restaurant, students at a university, the same way you treat batch jobs in a factory. You know, they come in, they go to a queue, you do something to them, you pass them on to the next queue, and so on. And that's the way most people think of service. Service dominant logic, which is sort of the overarching perspective on what we do in service science, has a different view of what service is. And it begins with a definition of value. Economists, traditionally, going all the way back to Adam Smith, measure what's called value in exchange. So when I wouldn't buy this computer, but if I did buy this computer, I might spend a couple $1,000s on it. I go to the store, I exchange money for the computer, and that gets counted in the gross domestic product, right? Economists recognize that as economic activity, as if value was created. But when we think of value, when I bring that computer home and it sits on the desk, it's a 2-pound hunk of metal and plastic, and it really has no value until I use it. And until I use it in my particular context. So we distinguish value in exchange from value in use and value in context. And this is the service dominant logic point of view. And what really matters is the value in use and value in context. If you think value in exchange really captures economic activity, look in your attic at all of the crap that you bought that you couldn't live without, right? And that was just sitting there. So that's the foundation of service dominant logic. And that leads to a definition, and I'm encapsulating a whole lot of stuff here. That leads to a definition of what a service is. And fundamentally, we define service as co-creation of value. What makes a service is that more than one party, 2, 3, 4, 1,000, somehow participate in co-creating value for each other. And a service system is something that enables that to happen. So then what is a product? Well, a product like this laptop is actually an encapsulation of service potential. By itself, it does nothing, but it has the potential to be a resource in co-creating value. So if you teach me how to use this or teach me how to use a particular software on it, all right, you're providing a service to me, and I'm providing a service to you. Okay, so in a nutshell, that's where we're coming from. I am there's another special interest group within Informs. It's called the Service Science Section, so we created that in 2007 in parallel with the other one. We're not nearly as big, so we are still struggling to educate our own community about what service really is. 90% at least of the American economy and the European economy is about service. And what's really interesting is even in emerging economies, we see 60, 65, 70% of the economy is actually service, meaning co-creation of value. So think about healthcare. That's one of the biggest topics in service today. Healthcare as a service. Education as a service. Government services, or government as a platform for services. Consulting as a service. Financial services. We're not just talking about restaurants and hotels. Think about where our jobs, our futures, and our economy is today. This is really what it's about, more than supply chain management. Okay, so let me get into this. When Christoph invited me to speak, it was an outcome of a meeting we had in March, at the end of March in California. I invited Christoph to that meeting. This was a workshop sponsored by ISIP, that is the International Society for Service Innovation Professionals. It's a fairly new society. And the National Science Foundation. And ISIP received a small grant from the National Science Foundation, and this is the second time they did it, to hold a workshop, and the purpose of the workshop is to draft an agenda for the next 5 years or so, to try to tell NSF, here are the areas of research that you should be putting money into. And even though National Science Foundation is a United States government agency, so they are not going to give any money to people in Switzerland, we still invited people like Christoph to the meeting because we wanted to get a lot of ideas from all over the world. And so I'll talk briefly about the workshop and what came out of it, a list of some research questions, try to direct future research, and maybe if there's time, talk about some current research related to data science that I've been doing. One final point to make about service is that besides being an emergent science, something that's new and really, really interesting and really, really important, I think we're reaching the peak of the hype cycle in data science. Do you use that term here, the hype cycle? Okay. And pretty soon, CEOs and other people are going to ask that embarrassing question that they've always asked about IT, which is, where's the ROI? Right? And the answer is going to have to be not in how cool all these models are and so on, but rather how you create services out of predictive analytics. Okay, so there you see the ISIP mission. We were founded in 2012. You can see this is our makeup right now. We have some, I wish I had as many corporate members as Christoph has for his unit. IBM, Cisco, GE, the Japan Science and Technology Agency. And those are the people who are funding ISIP. If you want to join ISIP, and I invite every one of you to join, just go to our website. It's free for an individual. And we've got more than 1,000 individual members all over the world in a lot of academic institutions. And if your company is interested in joining ISIP, I'd really like to talk to you. That's where the money comes from. Okay, so that's ISIP. Who's NSF? It's a federal agency that is extremely important in funding academic research throughout the United States. 24%. So 7.5, it's actually closer to 8 billion in fiscal year 2017. That may seem like a lot of money, but it's really not. My institution has an annual budget of about 1.5 billion. About half of that has to come from grants and contracts, research contracts, and a good part of that comes from NSF. But we're just one, just one university. Okay, so how does this break down? Well, the NSF is divided into 7 directorates, and you can see when we talk about $8 billion, it's spread pretty thin when you think we're doing geosciences and biology and engineering and everything like that. Nowhere in there is data science. There is no department for that. Nowhere in there is service science. You know, these are old definitions that have been around a long time. It turns out that the engineering directorate is the one that sponsored the workshop and the one that's looking for future directions for service science. And in particular, this program within the engineering directorate, the Partnership for Innovation, Building Innovation Capacity, is kind of unique at NSF because NSF is supposed to be funding pure scientific research. And this program is quite a bit different from all of those. It was designed to provide funding to cross the valley of death, as they call it. Now, the valley of death is this. When we talk about some new innovation, such as the one we just heard about, very often it starts in academia. Some faculty member has a great idea, some new vector model or something like that, or some new kind of technology. It's in the laboratory. And if that academic goes to a company like IBM and says, hey, I've got this great new idea, IBM is going to say, well, when you get it working, come back and talk to us, you know, but we're not going to fund that kind of research. even venture capitalists, and venture capital is very active in the United States, about a third of it comes in Silicon Valley, even they will tell you, get a prototype working and make $1 million and then come back to us and we'll talk about funding you for the growth. That's changing a little bit. It used to be that a venture capitalist was a typical Silicon Valley company of 3 or 4 people and maybe $100 million, but today the venture capital is coming from IBM and Cisco and SAP and companies like that, because at the same time that IBM is trolling for new ideas, there are more than 10 early retirement programs at IBM today. At the same time that Cisco is partnering with graduate students at Stanford University on some of their new technologies, they're laying people off like crazy. So what's emerging is an economy in which resource ownership is not what you're looking for. It's access to resources that matter. But nevertheless, even with that kind of capital, there's this gap between something in the laboratory and something that you can commercialize, and it's to fill that gap that this program was created. So in order to get a grant under this program, you need a company partner that signs a letter that says, yes, we will work with you on this project, but NSF is actually going to put the money into it in terms of getting the first prototype built and actually testing it and refining it. Okay, so our agenda was to tell that particular program what kinds of things on the horizon they should be looking into. So, smart service systems, human-centered service systems, that's what PFIBIC is really interested in. And so you can see from $8 billion, we get down to $13 million. This is still an area that is working towards recognition even within NSF. And this is a slide I stole from NSF. This is basically the way they look at things. There's engineering and technology, but in order to evolve into a commercializable product or service, there's got to be this side of it as well. Okay, so in the workshop, we took many perspectives to look at all these issues you see here. The verticals are industries like healthcare, agriculture, education, legal services, financial services, government services of all kinds, transportation, you name it. The horizontals are things like data analytics and IoT and things like that. Okay, so going to the first one, technology, the key thing that we made sure we focused on is not technology for the sake of technology. That's usually how the hype cycle begins, but we're at the point where what really matters is how do we use the technology. And the reason I'm looking at this bullet list is because there's also a lot of misunderstanding, I think, such as the word smart. You know, what makes a service smart? And we're hearing that all the time, smart this, smart that. And I would ask you to think, what makes you smart? And you're all smart people here. But are you smart because you have good eyesight? Is that what makes you smart?
Pattern matching.
Pattern matching. So it's not your eyeballs, it's what you do with what your eyeballs see.
Every human can detect something out of a pattern,
Yeah.
even the dumbest human. And the computer cannot.
Oh.
It's a trained system, always to be trained for every exception.
Okay, so you can interpret that, but your eyes only record data. So IoT, per se, is the eyes, the ears, the nose of a smart service system. But it's not, that's not where the smartness is. Smartness is in taking the IoT data and doing something with it. And in particular, if you can not just recognize patterns, but if you can learn from what you see. That's really where smartness is. So I find this, because of the abuse of the word smart, I find this a big problem. And I also find this a problem, that's why I highlighted it. I talk to a lot of really well-educated people, but the distinctions among predictive modeling, descriptive modeling, and prescriptive modeling is very blurry and to a lot of people unknown. And what I see in a lot of cases in data science is people are trying to predict decisions instead of predicting and estimating parameters that are used in support of decision making. And I think it's a good example is Google that fell on its face when it tried to advise the Center for Disease Control about where to send flu vaccines, thinking that their predictive model, based on website hits about flu, could tell them where the next flu outbreak would be. And they were totally wrong about that. That's an example of the abuse of predictive modeling. Here's a little diagram that kind of puts all of this hopefully into some kind of perspective. If you're thinking about making a decision, and that's really what smartness is all about, helping people make decisions. Where does predictive modeling fit in relation to all the other kinds of modeling? So this is, you could call it the contribution from service science to data science. Okay, I mentioned these verticals, they're really important. But I have to say these are now becoming obsolete definitions because what are the boundaries on the healthcare service system? Is it the hospital? Is it the doctor and the patient? Or is it your mother-in-law who gives you some advice? Right? Or is it the internet? Is it WebMD? Is it Facebook? Where are the boundaries of a service system? And we are walking very rapidly into a case of really intensive resource integration where we have 20 billion devices connected to the internet and networking of individuals and organizations rapidly advancing. You really can't put boundaries around a service system. The education system and the healthcare system, they're connected. It's a many-to-many service system. And so these verticals are kind of getting in the way of innovation. And so now we talk about service ecosystems. Okay, human factors was another big issue. IZIP and IBM have championed this idea. I don't know if you've heard much in Europe about T-shapedness, but a lot of companies in the US are really big on this. My own university has adopted this as an initiative for the whole university. We are training T-shaped professionals, meaning somebody who has deep disciplinary knowledge in something like data science, IT, whatever, but also has, across the top of the T, broad knowledge in order to integrate that discipline into something useful by knowing a little bit about maybe healthcare, finance, marketing, things like that. Okay. We also looked at business models, and business models are changing dramatically. Like I said, resource ownership is not the key. It's resource access and integration and resource integration. And unless you have a question about something here, I'll just show you the list and we can come back to it later. A big issue, and talk this morning, raise some of these ideas, is what kind of economy we're emerging into and how will governments handle it. Do we need a guaranteed national wage and things like that? Picking up on this morning's talk, how many of you have heard of HAT or are members of HAT? Okay, HAT stands for the hub of all things. It comes out of the University of Warwick in England. Irene Ng has been working on this for like 4 or 5 years. If you don't know about it, go to their website. You can join HAT. You get a newsletter. You can actually, HAT is about data ownership and creating a market for your personal data. It's a commodity. Data is a commodity now, so why not own it and trade it and have control over it. That's what HAT's all about. But if you're interested in all of the scary stories about privacy and security, they do a lot of research on it. Okay, now we get to the engineering part, and this is when things get technically interesting. So here are some of the questions that we asked, and we didn't have answers for NSF. We simply pointed NSF in the direction of where answers might be. But you can see what we're concerned about, human-machine interaction. And so where do we look for answering the first question? Well, obviously big data analytics and advanced IoT sensors. I'll just put these lists in here. I guess none of this is terribly surprising. But here are some more interesting questions. How can a human being better understand what a machine is thinking? Don't laugh. I mean, we're talking about robotic soldiers, right? Robotic police officers. We're talking about robotic teachers and so on. And yes, we are going to be trying to understand not just what one machine is thinking, because pretty soon we're going to have a lot of these machines and they're networked to each other, and human beings are on the periphery. So it's not just understanding what that one soldier is thinking, but what the chain of command is thinking, and how that soldier is learning from other soldiers and so on. So these are some really interesting, difficult questions, such as affective computing, that really need to be answered in the near future, I think, because these technologies are coming upon us very, very quickly. I thought this was an interesting engineering kind of question about control and stability. Like I said, it's not just controlling one robot or one application, it's about controlling the whole network of them. We don't know how that network is going to behave. Behavior emerges from it, just like with people. Somebody did an experiment not too long ago with two robots and gave the robots a simple task of like picking up blocks and putting them in a corner, and the two robots cooperated. There were plenty of blocks and they each had enough blocks to put on their table, and then when they reduced the number of blocks to the point where there weren't enough, the robots started competing and fighting with each other, basically. So we really don't have good command and control of these things. They're going to be here really quickly. The Japanese are really big on wisdom computing. This is a new field, and they've adopted the term Society 5.0. The Japan Science and Technology Agency is a good place to go to find out about that. That's related to affective computing. Okay, I don't know if you're into T-shapes, but in the United States, STEM became a really big issue for the last 20 years, and in academia, it's degenerated into a turf battle. Okay, so now we talk about STEAM because the arts people wanted to have their piece of the pie, and now it's STEAM, the H standing for humanities. Going back to engineering questions and control, command and control, and stability. Can humans take over when needed? My answer is no. We already have evidence of what happens when we become too dependent on machines. So we need research into making these things more robust. And getting a little fuzzy about this, but this morning's talk I thought was a good lead into this. Our society is going to change a lot. So there are some big questions yet to answer. Okay, I guess I'm out of time, so I won't. I've got some research that currently working on that's more prosaic and is looking at the issue of predictive analytics and the role of predictive analytics in supporting a service system, and how modeling the decisions is built on predictive analytics. So here's an example of work I'm doing with people at General Electric. And I just presented a paper in Naples about healthcare on this topic.